In this problem, we need to determine the coordinates of the vertex and the focus, equation of the axis and directrix, and the length of the latus rectum of this parabola. Let's begin. We'll start with the given equation of the parabola. So here we have 4 multiplied to y minus 1 whole square equals to negative 7 times x minus 3. Let's make some substitution here. Let's consider x minus 3 to be equivalent to x in upper case and y minus 1 to be equivalent to y in upper case. Then we have 4y squared equals to negative 7 times x. We're going to divide both sides with y, so y squared becomes equivalent to negative 7 over 4 times x. Now, this is the equation of a parabola, which is expressed in the standard form, y squared equals to negative 4ax. Now, if we compare it with the standard form, then we get the value for negative 4a. So that's going to be equals to negative 7 over 4. So that means a comes out to be 7 over 16. This is the value that we will be using. The whole reason we are expressing the original equation of the parabola in this new system, y squared equals to negative 4x, because this is a standard form of the parabola whose vertex is always going to be at the origin, and this is going to be a left facing parabola. Let's try to understand the graph of y squared equals to negative 4ax. So this is the graph of the parabola whose standard equation is y squared equals to negative 4ax. Negative sign tells us that it's a left facing parabola. Now, whenever we express the parabola in its standard form, the vertex is always going to be at the origin 0, 0. The coordinates of the focus is going to be at f with value negative a, 0. And the line on which the focus and the vertex lie is referred to as the axis of symmetry line. Now, in our case, the axis of symmetry line is the x-axis. So its equation is given by y equals to 0. Now, we have another point having the coordinates a, 0. Through this point, we have a straight line that's perpendicular to the axis of symmetry, and this line is referred to as the directrix line. So its equation will be given by x equals to a. And then we have the latus rectum. The latus rectum is the straight line passing through the focus of the parabola. It is perpendicular to the axis of symmetry with its endpoints on the parabola. Here, the length of the latus rectum is defined as the absolute value of 4 times a. So here we have obtained, in our case, a value is 7 over 16. Now what we'll do, we have represented our parabola in terms of the new coordinate system. So here we have the new coordinate system, x, y. What we'll do, we will take the help of the substitution x with x minus 3 and y with y minus 1 to go back to the old coordinate system. That means in the new coordinate system, we have defined the vertex to be at 0, 0. This simply tells us that the x value will be 0 and the y value that's equals to 0. So in the old coordinate system, all we have to do is replace the value of x with x minus 3. So x minus 3 equals to 0. And in place of y, we have y minus 1 that will be equals to 0. So solving for x and y, we get x equals to 3 and y equals to 1. So that means the coordinate of the vertex in the old coordinate system will be 3, 1. Next, we come to the focus. So the focus coordinates is given by negative a, 0. So here a corresponds to 7 over 16. So that means the coordinates of the focus in the new coordinate system is negative 7 over 16, 0. Now this means that the x value that's negative 7 over 16 and the y value that's equals to 0. Now, if we use the old coordinate system, then in place of x, we will be replacing with x minus 3. Now this will be equals to negative 7 over 16, which means the values of x will be equals to 41 over 16. Next, we have y equals to 0. So in place of y, we'll replace with y minus 1 equals to 0. So we get y equals to 1. This means that the coordinates of x and y of the focus will be 41 over 16, 1 in the old coordinate system. Now coming to the equation of the axis of symmetry. Now we have defined the equation according to the new coordinate system as y equals to 0. Now going back to the old coordinate system, all we have to do is replace y with y minus 1. So we get y minus 1 equals to 0. which means y equals to 1 is going to be the equation of the axis. Then we have the equation of the directrix of the parabola. So equation of the directrix in the new coordinate system is defined as x equals to a. So here a is 7 over 16, which means that in the old coordinate system we have x minus 3 equals to 7 over 16. So that will be equals to x will be equals to 3 added to 7 over 16, which will correspond to 55 over 16. So that's going to be the equation of the directrix. And finally, we obtain the length of the lattice rectum. The length of the lattice rectum of the parabola, that's going to be absolute value of 4a. So a here is 7 over 16, which gives us the value 7 over 4. Now, this value of the length of the lattice rectum is going to stay fixed. Whether we use the new coordinate system or old coordinate system, this value is always fixed because the shape of the parabola remains unchanged. So this is how we have successfully obtained the coordinates of the vertex, coordinates of the focus, equation of the axis, equation of the directrix, and the length of the lattice rectum of the parabola.